Let's build a RAG microservice on Docker using Python. I'll briefly explain what RAG is and do the same for microservices. Then I'll talk about my approach for doing these things and we'll get right into the demo. If you're new here, hey, I'm Alex. I'm a data engineer, and on Zazen Codes, I'm teaching full stack data science. If you like what I'm doing here on YouTube, then you could check out my premium content over on Patreon, and you can sign up for my newsletter for zero cost in order to support the channel. Links to all of this stuff, plus the open source code from this video's tutorial down in the video description. RAG stands for Retrieval Augmented Generation. Generally speaking, it's a hybrid modeling technique that integrates retrieval-based systems with generative models, or large language models, in order to improve knowledge-based generation. So when doing RAG, a retrieval system might look through a large corpus of documents in order to find the ones that are most relevant to the search query, and then pass those documents, the corpus of information, into a generative model so that it can provide a flexible answer to the question. These systems rely heavily on the language models to generate coherent language, and the retriever component of the RAG system typically relies on embeddings in order to determine the relevance of the search query with the documents and source the correct ones. So rather than traditional keyword matching, which would be something like term frequency inverse document frequency, this will be a sparse retrieval technique. These RAG systems typically use embeddings, which is referred to as a dense retrieval technique. That's because the information in an embedding is relatively dense in terms of a numerical vector representation of information compared to the information in a term frequency inverse document frequency vector, which is very sparse. There's a lot of zeros in that information. But that's just an aside. The key advantage, or the thing to think about with RAG, is that it's combining the accuracy of a retrieval-based system with the flexibility of a generative model like OpenAI's ChatGPT. And this is great for tasks that involve accuracy on a very specific corpus of documents, and also flexibility around being able to ask different types of questions. In other words, getting open-ended response generation from your questions. We're gonna cook up a very simple RAG pipeline and then bake that into a microservice. The main reason for doing this is to increase the hype of this video and get more people to click. The main reason for doing this is that microservices offer a scalable, modular, and resilient architecture. A microservice is a small, independently deployable service that typically does one business function in an application. By splitting applications up into microservices, we can help decrease the coupling between those services. Each microservice runs its own process and communicates with other parts of the application through simple protocols. For example, HTTP. That's what we'll be doing in this video. This type of architecture also allows for different technologies to be used in the application. So each microservice could be using a different software like Python or Go or Rust or C++ or whatever. It doesn't matter because we're exposing that system through a simple protocol like HTTP or RCP so that they can talk to each other that way. So what will our microservice consist of? We're going to be using Docker and Python. We'll build our RAG application using HAYSTACK, which is a Python library, and we'll build our server for the microservice using FASTAPI, which is another Python library. Inside of HAYSTACK, we're going to be needing access to a language model, and we're going to use OpenAI ChatGPT 4o Mini. And in order to do this, if you're following along with the demonstration, you'll need an OpenAI API key in order to access that model. For the demonstration, I'll start by showing a Jupyter notebook where we discuss HAYSTACK and how that works with Python, and then I'll be going into NeoVim and we're going to be looking at our microservice and then running it. I'll be doing this locally on my machine, but if you're interested in seeing how I would put this into production, then leave me a comment and I can make a video on that. So I've got the source code open here. You can just grab code and then grab this HTTPS URL if you want. And if I go into my downloads, I would just say git clone and then paste this URL in. Once you have that, you can go into Zazen Codes YouTube source and then RAG microservices Python, and that's where all of the code for this video is going to be. So the first thing I'm going to do is open up a new tmux session to work in. I'll say tmux new s. I'm going to call it Zazen, and now I'm in here and I can see I have all these files. So let's print a tree of everything, and inside of my data folder I have a list of Rick and Morty episodes from different seasons. So season 1 to 7, and let's check out what these are going to be. This is going to be my corpus of documents that I'm going to retrieve from, so we can ask questions about Rick and Morty. We'll look at the first, I don't know, let's do 20 rows. So this is our data. This is what it's going to look like. So it's semi-structured, but it's just text data. There's no columns. I'm not sort of telling the LLM or the RAG system about any sort of schema here. This is just going to provide my context. I could also go ahead and, instead of season 1, let's print season 7. That's the last one. And instead of the head, I'll print the tail to show you what the end of it looks like. And yeah, it's just the same type of stuff. We're going to talk through this notebook first, and then I'm going to talk about my RAG service down here. But in order to run the demonstration, we're going to need to install a virtual environment. So I'm just going to say python-m venv like this. And now we're going to install our requirements. So let's have a look at our requirements here. I'm going to open these up in Vim actually. And so I have actual versions. I really like adding versions in this way. But when I'm developing, I don't typically do that. So I will just say, okay, give me the latest version of all this stuff. I'll keep these versions here, but check out how I've removed these versions, because I just want to show you how I develop, how I build things. So I'll say venv bin pip install -r requirements, and this is going to install those inside of that virtual environment that I've just gone ahead and created. It's using cached versions of all this stuff, but for you it'll take longer because it'll have to pull all this. Now let me print my requirements again. Notice how I don't have versions of these, but it did pick the latest version to install. So if I say venv bin and then I say pip and then freeze, it's going to print all of the actual versions that we've gone ahead and run. So I have a little helper script that I call update py requirement versions, and when I run that, it's going to update my requirements.txt to actually have those versions from this pip freeze. So now when I print my requirements, we can actually see those versions have been hard-coded into my requirements file. By the way, this I just put inside of my bin. So update py requirements. It's an executable in my path, and if I just print that, so how this works is it's just a bash script that updates the requirements using this command I was showing you, pip freeze, and it has kind of this regex search, which just goes ahead and updates our requirements file. But anyway, I've posted this script in my Second Brain Notes repository. You can actually get this. There's a link that you get if you sign up for my free newsletter. And once you've got this open on Notion, you just go down, and this one's in code snip. And then I have this update requirements. You can kind of open that. And this is that script that I'm running. That's what I've got installed in my shell. Anyway, that's just an aside. So now I'm going to open up VS Code. I like to use VS Code for Jupyter Notebooks. So I've got a notebooks folder, and I've got this dev IPYNB. So this is what we're going to work in. And let's go to the very top, and I'm going to clear everything so we can work from scratch. So HAYSTACK is the library that we're going to use, and it has this, we're using version 2 of HAYSTACK, and it's got this in-memory data store. So I'm going to instantiate that, and then we're going to populate this with some documents. Now the first time I run this, it's going to prompt me to install a kernel so that I can run on my Jupyter Notebook. I don't have this in my requirements, but VS Code just goes ahead and prompts me for that, so I'm able to run this. Now I can install that and instantiate this document store. Now we're going to have to load our documents. Now I like using pathlib to work with my files in Python. So the data is in this data folder, and let me print that, and it's in this Rick and Morty episode. So if I just look in my data folder, and then I want to search for all of the text files inside of that folder. Let's see if I can actually do this tree command. I like that one. So let me break this one down. If I say I want CA like that, okay, now let's go up, and I'm just going to paste this part. And what do we get from this one? So it's a generator object. So what I could say is convert that to a list, and I'm going to get a list of, these are all my documents that I want. So that's down here. Actually, let's go ahead and define that. I'll say docs like this, okay, or maybe let's say doc files. You can run that. These are my doc files. Now I can go ahead and grab one of these. So I'll say doc files, and let's say 0, and I can read the text of that. And this is going to get me some doc content. But instead of, I was just loading one when I was testing this, but I want to load all of these. By the way, in Jupyter, you can say document like this and put a question mark, and then you can get information about this, what it's doing, what type of parameters you might want to put in here. So I have these doc files. That's what I want to work with in here. So I'm going to be iterating those, and I'll say for file in doc files. So what do I want to do with the file? I'll say file.read text. And this is going to be the content. And these will create a bunch of documents. So we don't have too many files, and they're all really small. So this ran like right away, and we've got all of these documents loaded as these HAYSTACK document objects. If I print the representation of that, we can see them in here. Next, we're going to set up some embedders. So I've got this sentence transformer document embedder, and I'm using a specific model called sentence transformers all mini LM L6 V2. So let's run this code. And if this is the first time you're running this, it's going to take a while because it's going to be downloading this model to your computer. For me, I've already got this model downloaded, so this should run pretty quickly. And I'll show you where that is. It's, for me, in this cache folder, in Hugging Face, and then in the hub folder in my home user directory. So it's gone ahead and instantiated this embedder, and let me print this code now, and you can see where it lives on my computer. I've just done grep because there's a bunch of different models which I have from Hugging Face Hub, and I just want to filter on this sentence transformers one. Next, let's take this document embedder and embed all of our documents. So I'm going to create a bunch of documents with embeddings by running all of these documents through the document embedder. So ran pretty much instantly, and it's all done, and now I've got this document store available. Now, since we were using this sentence transformers library above, we need to make sure that we're using the same library below for embedding the user queries. So I've got the same model defined here, and when we do our microservice, I'm going to have this as a config variable so that we're making sure to pass the same one. If we used a different one at this step, it wouldn't make sense because we'd be putting our text into a different embedding space. So we've got a separate way with HAYSTACK of doing text embeddings for the queries, and so I'm instantiating this text embedder, and we're going to see that in use below. Lastly, I have this retriever object, which I'm going to define as this in-memory embedding retriever. And you can see how in-memory, like HAYSTACK is designed to be able to do things at bigger scale. So it's going to have different classes that we can use for, say, an out-of-memory document store. And lastly, we're going to create a prompt template. And this seems to be the key step for our RAG pipeline that we're creating. I've been following some HAYSTACK tutorial for like a beginner RAG pipeline. And so this one is using a prompt builder, and it's creating a template here. And we're putting all of the document context into like a context prompt. And then we have a question, and we request an answer out of the model. And this is like a general template that's going to work well on all sorts of models, including not so sophisticated models like ChatGPT, although we are throwing this at ChatGPT using the API today. So we've got this prompt builder, and now I'll just show you how that might work. If we were to run the prompt builder and I could pass in all of my documents and the question like, who's the best character? But check this out. If I copy this and I just sort of paste it, look how big the prompt is. It's just inserting all of that text, from all of our documents into the context. And so at the very bottom, if I scroll in after all of this context, you can see our question, and it's like, who's the best character? Answer. So this is just inserting this text from all of our documents into the context. All right, so let's finish up this pipeline and do some test runs. I've got an open API key available in my environment, but if you don't have that, then you're going to have to go ahead and enter it. I'm not actually sure if this will run properly, but maybe what you'd want to do is just raise a value error and make sure you're going ahead and setting this. I'll say no, open API, and variable, something like that. That'll definitely work. But I've got this in my environment, so that means this is just going to work. It's going to pick up on that automatically because this is available in my environment. And I'm going to use this ChatGPT 4o mini model. And so this is what our final pipeline looks. We have all these pieces that we've been building, a text embedder, a retriever, a prompt builder, a generator, and then we're sort of like connecting those together. That's how HAYSTACK works to build pipelines. And afterwards, it's outputting like what our pipeline is going to look like, and now we can ask it a question. So I'll say, what's a MICROSERVICE box? This is a Rick and Morty thing, and I'm going to sort of request the answer to that by running the pipeline. And I'll get a response back, and I can parse out the replies and print that, and we're going to get an answer. So it's a fictional device in the animated television show Rick and Morty. Now, this sort of question could have been answered probably without any context, because I think ChatGPT would probably know just out of the box what a MICROSERVICE box is. So let's try something else. Here I'm going to say, okay, give me a list of all the episodes about Jessica in JSON format, and I'm specifying that that format looks like. And this is very general because I haven't given it any context. If I was just to ask ChatGPT, it wouldn't know the context of what TV show we're talking about to find information on Jessica. And even if it did, right, it wouldn't probably know the exact information that I have available in my data set. It might have a difficult time actually pulling out all the episode numbers and providing good descriptions of them along with their names. So let's run this and see what we get. So here's the result. We have season numbers and episode numbers as requested. Interestingly, this episode number 24 is totally wrong. There's not more than 10 episodes usually in a season, so I don't know what's going on with that one. If I scroll down a little bit, we have like season 5, episode 1, 6, 3, this all adds up. And if I search Jessica, we can see it's sort of like describing how she is in these episodes. So it's a pretty good answer based on our corpus. Again, I'd have to look into this one. That's not great. But let's talk more about the response in general, what it looks like. Some metadata that I'm interested in, like the model and how many tokens it took. So the completion took about 400 tokens, which is very small. But look how big our prompt is. This RAG pipeline we've created has a really expensive cost with the number of prompt tokens that have to be used, because you saw how big our prompt was. And I'm going to compare this to if I use the tick token library and I want to get a tokenizer and I want to see how many tokens the prompt uses. So I can go back to the prompt builder, which we had, and this is part of our pipeline. But now I'm just going to run that and pass in all of our documents and the question. This question variable is that Jessica one from earlier. And I can get the number of tokens that it thinks we're going to use. And it's coming out to 23,130. And that matches pretty closely with the prompt tokens that were actually used by this request. I did this because I was trying to figure out how this RAG pipeline works. And in our case, with this simple beginner demonstration, how it's actually working is really simple. It's just like slamming all of the context as text right into our model. That being said, this framework is the starting point for building more complicated RAG pipelines with the HAYSTACK Python library. So now that we have an understanding of that, we're in a good place to open up Vim and look at our microservice. So in here, we're in this RAG Microservice Python folder where we were before when we launched VS Code. And if I look, I have access to this virtual environment Vim, which we set up. So I want to activate this. So I'm going to say source vem bin activate. And now over in my terminal, I'm getting this kind of helper that's saying, okay, we're using this virtual environment now. That way, if I type Python, where I'm using the Python in this virtual environment. So that Python there would be a shortcut where instead of having to type vem bin Python, my default Python is going to be matching this now in this shell. And why I've done this is now when I open up NeoVim, it recognizes that virtual environment and it's going to give me type hints on my code. My code, by the way, is in this RAG Microservice folder inside of a file called app. And this is my FASTAPI app. I just scop down, this is the app object right here, and that's what we're going to be running. And the way we're going to be running this is using Docker. So if I go to my Docker file, I have a command at the bottom, and that's running that app. It says, look in the app file, and then look for the object app inside of that file. If I go back to my file, that's this object right here. I'm going ahead and running that with Docker. And now let's look at how I'm actually going to run that with a command, and that's going to be in this run app.sh. So I have a shell script, which is going to run my app for me in one command. I just run this shell script. But what it does is it first builds this Docker image, and then it runs that as a Docker container, and I have some volumes that I'm mounting. I'm also passing this environment variables file. So let's start with the README. README is a great thing to write ahead of time because then it sort of has your spec and then you just update it as you update your app or change your spec. So first thing is to create an environment variable file and add the OpenAPI API key. So how that might look is I want to add a file. I'm going to call it .env and then I'm just going to call it .demo, but you would actually want to name it .env exactly. Now I can grab this here and open up my file and we're going to want to paste this in. And then here you need to insert your actual OpenAI API key. Now the request that I'm going to be making, so something like this, cool, save it. That's the file we're talking about. I have this available as a .env file. So if I say LSA down here, I've got this .env file, but I don't want to show you that because that'll have my actual API key that I have connected to my account. And the calls we're going to be making in this video shouldn't be too expensive, but it will incur costs. So keep that in mind with this if you want to actually do this demonstration. So that's this line here. I'm just defining what my end file is. For example, if you actually did want one called demo, you could do that, and then it would load that one up. But I don't want that. And next we're going to have a volume, which is our data. So let's talk about the data. And I'm going to look in this data folder, and I've got all these Rick and Morty episodes. So it's actually in a subfolder inside of data. Like if I said ls data, I got a folder in here, and then inside of that folder is where all of this data lives. So the README for that, I'm just saying where I got this data from, Wikipedia, the date I fetched it. And then down here, I have a different file for each season, and these are just text files, relatively unstructured data. There is some structure to it, but it's not in like a CSV format, it's not in a JSON format. I'm not telling our RAG system anything about this. I'm just going to be like passing all this text in as context for our RAG system. So I'll go back to run app, and the next line is to get a volume that's going to share our app code. So I'm saying, look at my local system and take this RAG Microservice folder and then share that and mount it as a volume and share it inside of my Docker container in the home root directory and then app like this. And then lastly, this is just the name of the Docker image that I want to run. Well, up here we have some port mappings because I need to share port 8000, which is where my FASTAPI server is running, from inside of the container here to port 8000 on my computer. That's what the port mapping does. And then the D just runs this in the background, detached mode. So let's now talk about the Docker file. Get out of that. So I'm working in Python 3.12, and I just say, okay, switch to the app folder. This is where I want to work. So after I copy my requirements, I'm going to install them. And here's where, below this is where I'd want to say, okay, now I want to copy my RAG microservice into the folder. And the reason why you'd want to do that after installing your requirements is because then when you make changes to your code, the Docker image doesn't need to rebuild all of these requirements and reinstall everything. This is going to get cached inside of the image so that when we make changes lower down, we don't need to reinstall things. We just start from the latest cached version in our build. And so that's why you wouldn't want to just copy everything, but you'll see Python code where we're just copying the requirements, installing those, and then we copying the source code. However, since inside of my run app, since I'm doing this line here and mounting it as a volume, I don't need this. I don't need to do that. So next, I'm setting this just to make sure Python outputs are rendered. This is a good thing to have if you're doing a Python project with Docker. And then I'm defining some variables, and these are going to tie in with our file. You know, as opposed to hard coding things inside of our file, for example, I could have just defined these here at the top. I want to pull like configuration type logic out of my actual code, out of my actual Python library code that I've written here. I want to put that at a higher place, like a higher level, and this is a good place for me to do that. I could also do these as runtime variables. So if I go to run app, let's look at this one. Say open API generator model, say I didn't always want to use that. Well, down here I could say, okay, I'll just set that as an environment variable at runtime, and maybe I want to use the full GPT-4. And so I could do that this way. Down here, I would just comment that out, and this would work just fine. Now, I don't want to do that, so I'm going to get rid of that, go back, and I'd like to just have it hard-coded here, so I'll get that out. And what are we doing here? I'm just saying, well, here's where my data lives. Okay, we're looking for text files. This is our text embedding model, and then this is our generator model. And we're going to see where all of this is used in the code. And lastly, I'm just have my command to actually run the server. So now I'll talk through the whole application. I'm going to open up app.py. Actually, I'm going to say %bd to get rid of all of this stuff, and we're going to start fresh. Now, my linting tool is in action here. It's telling me I don't need this, so I'll get rid of that. Hey guys, just a quick interruption to announce my new course, Building a Demand Forecasting ML Application. It's in the same style as all of my YouTube content, but it's long form. It runs over 5 hours, and it shows you the full end-to-end data science project pipeline. I've got the first hour of that course available for free on YouTube, going to data exploration and feature engineering with Jupyter Notebooks. And in the second half of that course, we carry on to do modeling, and then I implement this as an ML application using Docker. So it's very similar, that second half of the course, to the style of this video you're watching right now. Speaking of, I will let you get back to that. Thank you. So let's start by walking through the FASTAPI part. I'm going to go down here and follow this to app equals FASTAPI. This is our instantiation of our API server. And now I'm going to follow app down. And here I'm just using the star symbol. Like if I type star like this, that's how I can search with NeoVim. I can also use the hash symbol like this one here to do searches. So I'll show you what I mean. Wherever I had app right here, I'm using the app object. So if I type the hash symbol, it's going to skip up to the previous use of app. And here I have it up here. So I can press the star now to skip down. And that's kind of how I like to walk through code with NeoVim. In addition to other, helpful ways of looking at code. For example, this to just hop between my definitions, or this one to hop through white space in the code. Anyway, I have app, so I can type N right here to go to the next app. Here we go. So this is where we're using the app for the first time in our code. And I'm saying when we start up, I want to run this. I want to load our pipeline. I only want to do this when I start my API server. I don't want to have to load my whole RAG pipeline every single time someone makes a request to my server, which, by the way, the request is down here. I'm defining a post method to be able to speak to our API. We'll talk about that in a second, but let's focus on this startup event first. And you'll notice my linting tool is complaining at me. It's like the method on event is depreciated. It does not want me using this anymore. That's a warning that FASTAPI is issuing, and my linting tool is picking up on that. But check this out. If I go to my requirements, like I'm using this version of FASTAPI, and so every time you install this project, it's going to pick that version. It's not going to use a more recent version. That means even though this is issuing a depreciation warning, it should keep working. It won't actually break on me. So what I did is I have a little to-do note where I should be using lifespan events. If I just close my file tree, you can see it's telling me use lifespan event handlers instead, just to the right hand side. So what I did is I went online and I could go ahead and select here, and I just pulled up a URL that has this lifespan event documentation. So with NeoVim, I could type GX and it'll go ahead and open that. It popped it open in a different browser I have. But yeah, this is like where I could read more about this and go ahead and implement like what they want me to do. But I'm not going to worry about that for now. We're just going to keep walking through the code because this is going to work fine for us. So what this does is loads our RAG pipeline. And this is going to maybe take a little while. It has to download some stuff or just set everything up. And after we've set it up, I'm going to store it in this app state. So app.state.rag pipeline equals RAG pipeline. Now let's look at where I'm using that. And this is going to be in the ask endpoint. So it's a post request, which means it's taking in this request object. And FASTAPI has a really cool way of inputting data using Pydantic. But for now, let's just look at how we use this request object and how that works with our RAG pipeline. So down here, I'm saying like, okay, we have a RAG pipeline and I'm going to use it locally now, and it's going to be of the type pipeline. Let's actually search that up. That's a HAYSTACK object of pipeline type. Okay, so this is just a type hint, and then I'm saying it's okay, let's just reference the app state RAG pipeline. So this is not actually like copying data or anything like that. It's just like a shortcut. So now I can just call it RAG pipeline. And it's also a nice code practice to be like, okay, this is a pipeline object, so we know what we're working with here. And then where I use that is down here, and I say RAG pipeline.run, and I'm passing in the data that I want to run. This is exactly what we did in our Jupyter Notebook when we run our pipeline. And check this out. I'm parsing the question out of the request. So it's going to be a field of our request.question. That's pretty cool. And then I'm just returning the answer where I'm parsing that out from the LLM answer and creating it into a new dictionary object that we're returning. And then if something goes wrong, I'll throw an error and I'll return that. And lastly, I just have a quick health check endpoint, which we're going to try just once we get everything running to make sure it works. Because the idea is like this endpoint will cost us some money. So it's not a great idea to use this as a test to see if our API is working or not. This one's free, so we should be using that simple GET request to check that everything's working once we have this running. By the way, if this line is still a little confusing to you, I just wanted to show you something. I could also do this, like just do that. That would work just fine too. You know, it's the same like if I did this and I said, okay, well, that's going to be my question. That's going to be a question. That works. Nothing wrong with that. But this is not very like in line with the, Zen of Python, because we're doing too much in one line. Look how much harder that is to read than when it's in this state. Much nicer to read like this. I want to discuss what this request object is going to look like. You can tell I'm saying it's of type question request, so I'm saying that's the type to expect. And here's how it works. I inherit from the Pydantic base model. I can go here. This is from Pydantic, looking at the base model, and then I'm just defining, it's like a data class type thing. So I'm saying, okay, the question is what we're taking in, and it's going to be of type string. Say I wanted to define the model at runtime. I could also do that, you know. I could also say like something more interesting, like the model has to be GPT-4, import literal this way. Nice. So I could say, okay, I'll take it in a GPT-4 model, or I'll take a GPT-4 mini model, but it has to be one of those two types, and I only want to get one of those in. But yeah, I'm not defining the model in that sense. I'm defining the model with an environment variable up here. That's actually what this line does, right? And where are we using that? Well, in order to understand these lines here, now we're going to walk through what our actual pipeline is. You've already seen this in the Jupyter Notebook, so let's just walk through the code and see how I put this into a microservice. First, I want to create the document store. I'm being really explicit about like doing things in small functions and what they return, and then we're going to like stitch all of these things together. And so let's show you that. This is where I'm stitching it together. We already talked about this startup function that we want to run to create our RAG pipeline, and this just goes ahead and calls out to all these functions. So everything's really clear how it's working, and all of our functions are like small and focusing on usually only one thing at a time. So I got my in-memory document store. Next, I want to actually embed my documents, put the documents from the volume that I'm sharing, all these Rick and Morty episode descriptions, and it's putting this into these document objects here. So I'm saying, okay, look in that path and then do this glob search ****star.txt. Find all of the text files, give me those as doc files, and then iterate over those, reading the text, and then put that text content into these document objects. So next is step 4. We create a retriever, and then we're getting a prompt builder. We're creating our prompt template, and this is where we're inserting all the text like we saw in the Jupyter Notebook yet again, and it's the exact same thing. I've just bundled it up into functions. And then lastly, we're creating a generator, and this is like the model part of the RAG pipeline where we're using an OpenAI generator, using ChatGPT to talk with us. And here I'm creating the RAG pipeline. So this is probably the coolest function in here. And we instantiate our pipeline. We connect all of these things together. All these different outputs of all these different functions sort of come together into components. And that's called here at startup time. So we've gone through the entire application, and now I can run this. So I'm going to open up a new pane here, and what we're going to want to do is call this run app.sh. But rather than just calling that, like, I want to actually run it one line at a time so we can talk about how this is working. So you should have Docker running. If I do Docker version, you should see some information about that. And also you could have Docker desktop open. So I'm going to open up my Docker desktop. I don't have any images or containers. So we're going to see this image get created right now. And I'll build it, and I'll just say build from where I'm at, and call it Zazencode's RAG Microservice, and give it this tag of latest. Inside of here, it's not using any cached files. It's actually having to download all of this because my Docker image, it doesn't have access to the same environment that I have locally. So it can't use the cached versions. It's going to have to install everything from scratch. So it's downloaded everything. So that's completed. And if I go back to my Docker desktop, I can see that right here. I could use this to like run it if I wanted to, but I want to do all this with the command line. Let's go back here, and I can also say Docker PS, or that doesn't show anything because nothing's running. I could say Docker image ls like this, and that's my image right here. By the way, look at how big it is. It's 1.14 gigabytes. I believe that's because of the virtual environment or like the Python libraries that I installed. I think it downloaded quite a lot of data from those ones. So let's see, if I actually say du.sh and then venv like this, I want to see how big this is. And that's about a gig, just this virtual environment folder on my local system. So most of the size of this Docker image is due to these libraries that I downloaded. Now it's time to launch this. So let's go back to my run app, and I'm going to run this Docker image, and I'm going to run it as a container. Like a container is a runtime instance of a Docker image. So I'll paste this in, but check this out. I don't want to run it detached. I want to run it attached. So I just keep seeing all the output, and you'll see how that works. So I'll run this off, kick this off right here, and look at the output that I'm getting. It's saying, okay, the server's beginning here, and now oh, look at all this stuff. Okay, let me go up a little bit and make this bigger. Okay, I'm gonna go up. So the first output I see is this, instantiating RAG document store. And so if I go instantiating RAG document store, it's calling this create document store. It's running through all of these functions in the on startup event. Let's go back here, and I'm going to keep walking down. So we're loading documents for RAG. We get some outputs and warnings and stuff. We're embedding text with sentence transformers. We're getting a prompt template. We're using GPT-4, okay, and then we're done building the RAG pipeline. And so this all built at startup time. That's what I'm trying to get at here with all this logging. This is not happening every time we make a request. And now it's ready to go. It's just like running, and it's running on this server. It's ready to make requests on. But I can't actually like make those requests down here. Like this is just doing nothing. That's why I might want to run this in detached mode. But I'm actually just going to open up a brand new pane, and we're gonna like run this here. So I'll say cat, where were we? This is what I just ran, the Docker run. So I could say Docker, let's say Docker PS, and I can see that running right here. I could also go into Docker desktop, up into my containers, and you can see this guy running. And it's just giving it a name. Now let's hit this with some requests. And I want to go to my README, and I'm gonna look at some requests. So the first thing I could do is a health check. Let's do this. It's just a GET request, and now you can see some logging here. So let's let's make this. Can I make this a bit bigger? We're gonna make that a bit bigger. Okay, cool. So yeah, so I got some logging. I kind of wrecked it. Let me make a few more of those requests. So check it out. I'm getting these logs here. Okay, 200 status codes. Cool. So next, what I want to do is make a more interesting request, and this is actually gonna kick off like a call to OpenAI. And I'm gonna say this one: what is the MECX box? And I'm making sure I'm saying, okay, this is gonna be application JSON. That's the data type that I'm sending you. And this is the data itself, and this is the data what I want to send, and I'm getting this. I'm passing this question inside of the data field. And so if I go back up and go back to my app, and remember, what was the endpoint called? It was ask. Let's go to that one. Where's ask? Here it is. So I said ask question. I have a request, this question request, and I'm saying this is a field I expect in my request. There better be a question in there, and so that's why I've got a question right here in my data. And so it gives me my answer, and it's exactly what I'm like looking for. And above here, I'm getting some logging about post, ask. Whoops, I accidentally just spun it down. Let me bring it back up. And meanwhile, I'm gonna go back to my README, and we're gonna ask another question. Notice, by the way, it's having to do all of this again. It's like instantiating the pipeline again. Now it's up and running. And I'm going to ask another question. I've got one prepared here, and it's saying, okay, give me a list of all the episodes about Jessica. So it's that same question. And we'll see what it gives us. That one actually took a fairly long time to come back. So if I search Jessica, I can see more references to her, so it looks like it's working. Now that we've got this thing up and running, let's ask some more interesting questions. I'll go back up here, and instead of this question, let's do something new. I'm gonna say, show me what you got. This is pretty funny. Sure, here's a summary of some key elements. By the way, I'm sick of looking at this badly formatted JSON, so I want to do something about that. Let's ask another question, but this time I'm going to pipe it out, and I'm going to say, put this into a result.json file for me. This time I'm going to say, give me a diagram of all the relationships in this show. All right, now I'm going to open up that result. It didn't log it because it put it into this file here. So I want to format this so it looks nicer. There's a way of doing this using JQ, and inside of NeoVim, I can open up my command, and I'm going to say %, and then I'm going to say exclamation mark JQ space dot. And now that'll go ahead and format this. Unfortunately, it didn't format this very nicely because this has all of these new lines. What I could do is I could copy all of this text. I'm going to say space Y to copy that. And maybe I can try and print this somehow. Let's see. If I open up a brand new window here, and I'm just going to go into Python, and maybe what I can do is just, yeah, I could go ahead and print this. Let's do it like that. All right, this is a little bit nicer. And okay, so what do we got going on? The main characters and relationships. We got Rick, father of Beth, grandfather of Morty, okay, and then I got this kind of cool diagram here. Key external relationships, Rick and the universe, Unity, President Morty. This is awesome. Okay, cool. So it's figured out quite a lot of stuff. By the way, I'm not actually doing my run. I never actually ran this run app.sh. So let's do that now. If I look at, since I've shut this down, if I look at, say, Docker PS, it doesn't look like anything's going on. But if I do this with an A flag, I can see all of these old ones that never got cleaned up. So in order to remove these, I could say Docker container rm, or prune rather, like this. That would be prune, like that, and it says, okay, do you want to remove all the stop ones? Cool, yep, do it. So I reclaim 280 gigs of space. Now if I do this PSA, I see that nothing's running here. So what I want to do is do this run app.sh like that, but I want to make a few changes. One thing I want to do is clean it up after. So I'm going to add that little flag. I'm going to say run it in detached mode and clean it up. Do this rm. And to make that maybe a bit clearer, I'll put the port mapping on a new line. There's a bunch of important stuff we're doing. And let's run this now. So I'll take this. Actually, no, we're just going to run this bash file. So I'll say run app.sh. And all right, ooh, it didn't like the rm. Yes, right. I needed probably 2. Yeah, that should work. All right. So I fixed that typo and it's running it. And let's see, it just gave me a hash. Like it's done, right? I can type code in here. So let's see what's going on. It looks like it's running here. And if I go over to Docker desktop, definitely is running here. It's got a different name now because, you know, I stopped it, reran it. And what else is going on? Well, I can check out some logs from that. Let's say Docker logs, and now I'm going to pass the name of it or the container ID. I'll use the container ID. I'll just say 9F. The first 2 digits should be fine. And so these are all logs from the container I just started. It's gone ahead and done all this, and now it's ready. It's ready to do some stuff. So let's run a curl command. Where's my history? All right, so I was giving me all the relationships in the show. Let's not do that. I'm going to ask one last question, and I'm going to use more of a conventional RAG retrieval thing. I'm going to say, what is the episode where, and now I need to ask something. I'm going to say there's the big talking heads. All right, let's see about it. The episode you're referring to is Get Swifty from season 2. In this episode, a massive alien head called Cromulon appears over Earth and demands to hear an original song. That's exactly what happens, leading to a musical talent show where the planets fail to impress and are destroyed. What a great episode. So Docker PS, now I want to shut this down. And let's look at the log command. I said Docker logs 9F, and I'll do that. And now I'm seeing like the logs from these requests that I've been making. And now I want to bring this all down. So if I say Docker PS, I can say Docker stop, and then I can use the same ID. I'll say 9F. I'll get that stopped. And if I look at Docker PS, it's done. If I look at PSA, it's not here either because I passed that RM flag, remove it, like clean it up when it's done. The only thing left is my image. If I say Docker image ls, I'll see that that image is still here on my computer, taking up a bit of space. So I could also clean that up. And I could say Docker image RM, and then I'm just going to pass the name of this in order to get rid of that. Now if I say Docker image ls, that's all gone, and it'll have to install this from scratch next time I want to run this. And that's it. We've built a fully operational RAG microservice with Python and Docker. Now, the RAG pipeline we implemented with HAYSTACK is really basic. It's just from the getting started docs of HAYSTACK. But what you could do is extend this with HAYSTACK's more advanced functionality in order to make this system more badass. And that's what you'd want to do if you were like implementing this in practice for yourself. There's HAYSTACK also has other functionality around loading different document types. You know, we just loaded text files, which would be pretty simple, straightforward to do with just plain Python code. As well, our prompt template there's not too many advanced things going on there. We're just kind of inserting some document text into it. But as you get into more like different types of media that you want to search over, like PDF documents, HAYSTACK's got ways to do that. And then also we've used like in-memory document stores, but HAYSTACK would have ways of storing documents outside of the memory of your computer, so you can start doing things at scale. It also offers all of these abstractions so that your code won't necessarily look that different than the code we've written in this video, even though under the hood it might be doing drastically different things. And so lastly, if you'd like to see how I would deploy this microservice to a cloud service like DigitalOcean or AWS or Google Cloud, let me know in the comments below, and I'd love to show you that in a new video. If you've stuck around this long, then I'd appreciate it if you could give me a like and consider subscribing if you like the types of videos that I'm making here on YouTube. Namaste.